For this method, the first step that we need to do is we need to separate in terms and call each term by a letter. For example, this one, letter A, B, C, D, and E. So we have 5 terms in this chemical reaction, and I'm going to call them with a letter. Then, what I'm going to do is I will list the elements the same way I do when I balance reactions. First the metals, then the non-metals, then hydrogen and oxygen. And what I'm going to do now is I will compare the amounts of each element. So for example, zinc. In what term do you find zinc? In what letter?
A and C.
So in the first part you have one zinc that is located in the letter A. The arrow is going to take the place of an equal sign, and in the products you have zinc located at the letter C. And because you have only one zinc, you will write one zinc. So here the way you read it is you have one zinc located at A and one zinc located at C. Then I will do the same for nitrogen, hydrogen, and oxygen. Nitrogen. Where do you find nitrogen? How many nitrogens and where?
In letter C, you have 2 nitrogens, and in letter D, you also have 2.
In the first part, you have in letter B, you have one nitrogen. Okay, we always start with the left. So we say one nitrogen that is located in the position B is equal to, as you say, 2 nitrogens at C. Okay, so I'm going to write 2C plus, and then I also have 2 nitrogens located at D. So I say 2 nitrogens at C plus 2 nitrogens located in the position D. I have nothing in E, and I will continue. Hydrogen. What will be the equation for hydrogen? What will be the equation for hydrogen?
It will be 1B equal 2E.
2E. What will be the equation for oxygen?
It will be 3B equal um, hmm, it will be 6C plus
Mhm.
1D plus 1E.
Okay, so we have 3 oxygens in B. Mhm. We have 3 times 2 or 6 oxygens at C. We have only 1 oxygen at D and 1 oxygen at E. And those, my friends, are the equations that we are going to use to balance this chemical reaction. Now, the next step, after we have all the equations, the next step is to see what letter is repeated the most amount of times. Okay, so to do that, we need to compare. For example, the letter A is located just in here. The letter B is located here, here, and here. The letter C is located here, here, and here. The letter D is located here and here. And the letter E is located here and here. So what letter is repeated the most amount of times?
Letter B and letter C.
B and C are repeated both. C times each. Okay? Now, we can either choose B or C. For the purpose that, for the next step, we can either choose B or C. But I recommend to use B because your equations are already isolated for B. As you can see, it is easier to work with B because it is in this side of the equal sign, and it's easier to work with these equations. So my recommendation is try to use the letter that is repeated the most amount of times in the left, okay, instead of the right. So between B and C, I would recommend to choose B. And what I'm going to do now is I will assign a value to B, okay? I will say, for example, I will say that B, tell me a number. Tell me a
10.
number. 10. 10 is a good number. Now, question. What number is easier to work with in the... Think about the table of multiplications. What numbers are easy to work with? Las tablas de multiplicación, ¿cuáles son las más fáciles?
5, 2, and 10 and 11.
But the easiest of all of them?
1, 1, 2, 0.
1, 2, 0. Okay, 0 cannot be used. Okay? 0 cannot, porque estaríamos como cancelando, eliminando elements, so it cannot be used 0. But, I mean, you can use 10, and that will be fine. But that means that we're going to work harder by using 10. But if you use 1, 2, or even 3, or 5, it's going to be a little bit easier. Now, I can work with 10, or I can make my life a little bit easier by using one of these values. Both ways are going to work, okay? It doesn't matter. If you want to use 100, use 100. But think, for example, just imagine that you have a fraction 1 over 2, and you have a fraction that is 50 over 100. What fraction looks simpler? The two fractions are the same, but which one looks simpler?
The first one.
The first one. The first one looks simpler. So let's try to work simpler. And even though you will see that that we work with number 2 or number 1, the procedure is going to be not so simple. Okay? So what number do you prefer to use? 1, 2, 3, 4, 5. Using 1 is a good number. I like to use 1 a lot. But here's the thing. Okay, yes, I'm going to use 1. To the other section, I teach them with 2. You will see the reason. Now, my personal choice is to start with 2. Why I choose 2? Because when I am balancing chemical reactions, cuando yo balanceo por tanteo, I always begin with 2. Yo siempre comienzo con el 2. I mean, in a normal balancing equation, yo siempre comienzo con el 2. If it doesn't work, I continue with 3, with 4, 5, and so on. Yo siempre comienzo con 2 in the normal method. Y también en este método, también comienzo con 2. Now, it doesn't mean that if I use 1, it's going to be impossible. No, it just means that I will be out of my own box. Solo significa que me voy a sentir incómodo. But let's try with b equals 1. We're going to assign a value to b, and we're going to try to isolate the rest of the letters just by knowing that b is equal to 1. Okay? So, I will start with all my equations that begin with b. So I have 1, 2, 3 equations. What equation of the 3 of them is simpler? which
Two.
equation is simpler? The number 2. So I always recommend to use the simpler equation first, okay? So the number 2 says that 1b is equal to 2e, okay? The number 2 is already used. Now I will replace by the values that I assigned to b. Okay, 1 is equal to 2e, and to isolate e, what I'm going to do is I will divide by 2 each side of the equation. So these 2 and 2 will be cancelled. So it says that e is equal to 1/2. Okay, so right now I already have the value of e. E is 1/2. And I already finished with my first equation. Now, this one is already finished, so I place a mark. Now, what equation, 1 or 3, is easier to work with?
1.
1. In 1, we have 1b equals 2c plus 2d. Okay? If you see, I already know what b is, but I don't know what c is or what d is. Okay? Yo tengo dos incógnitas ahí. Now, let's analyze the other equation, the number 3. I have 3b equals 6c plus 1d plus 1e. In this one, I also know b, I know e, but I don't know c nor d. Okay? So, as you can see, in the 2 remaining equations, I have 2 unknowns. I don't know c, and I neither know what d is. So what I'm going to do is, I'm going to take the simpler of the 2 equations. Which one is simpler, a or b?
A.
So I'm going to take the simpler equation, which is a, this one, and I will isolate for a variable. I can isolate for c or d, okay? So I will replace by the givens I know. I know that b is 1, so this is equal to 2c plus 2d. Now, what variable do you want me to isolate, c or d?
D.
Okay, if I isolate d, that means that I need to take away this. So to eliminate that, to get rid of it, I will subtract it from the 2 sides of the equation. Okay, so these 2 will be cancelled. And in the end, I will have 1 minus 2c equals 2d. Okay, but as you can see, d is multiplied by 2. And to get rid of that 2, I will divide by 2 each side of the equation. This division will allow me to get rid of the 2. Okay, so in the end, this will be 1/2. I copy the sign, and then 2/2 c. And all this is equal to d. Now, 2 divided by 2 is 1. Okay, so in the end, this equation is 1/2 minus c equals d. now I know what D is. I know that D is equal to 1/2 minus C. Okay, I know that. So this equation is going to help me after to find the value of D. But right now, I'm just going to leave the equation like this. I continue working and I continue working with my third equation. In my third equation, I will replace the values that I know. I know that B is 1, and I know that E is 1/2. That's why I didn't want to use 1, because there are too many fractions. But anyway, I will continue. 3 times 1 makes 3. This is 6C plus 1D plus 1/2. Okay? Now, remember that now I know what D means. Okay? I know it from the step before. I know that D is equal to 1/2 minus C. So that I will isolate it in here. I will replace the value of D by the equation. 3 is equal to 6C plus 1. And I will write the value of D, which is 1/2 minus C. And I continue writing the remaining of my equation, that is plus 1/2. Now take a look here. Here I am multiplying times 1. Okay, so it's not going to change anything. But imagine that in here I have a number that is different than 1, for example, a 2. I will have to apply distributive property. So this is not the case. This is not the case. And that's why here, all we do is we're going to get rid of the parentheses because the multiplication is going to give us the same numbers. Okay? 1 times D is going to give me all that. Now, I will add the like terms. Okay? For example, 6C and C are like terms. So they're going to be subtracted. 3 is going to be equal to 6 minus invisible 1, which is going to be 5C. And these other two numbers are like terms. 1/2 and 1/2, they are like terms. Okay? And when you add 1/2 plus 1/2 gives you 2/2, which in the end is just 1. So 3 is equal to 5C plus 1. Now you isolate for C, and to get rid of the 1, you will subtract it in the 2 side of the equation. So these are going to be cancelled. And in here you will have 2 is equal to 5C. And then to get rid of the 5, you will divide by 5 in the 2 sides of the equation. 5 and 5 will be cancelled. And you have the value 2/5 equals C. Or C equals 2/5. We already found one more value. Okay? 2/5 for C. I'm going to write it over here. 2/5. Now, if I know C, I can find D. And that's exactly what I'm going to do in this moment. D is equal to 1/2 minus C, which is 2/5. How much is this? How much is this?
It is 1/10.
1/10. Okay. So with this, we find the value of d, which is 1/10, and I'm going to write it right here. 1/10. I'm going to rewrite this. And now, what equation I can use to find a? What equation I can use to find a? The only equation that you
The
have
first
is
one,
the first one. The one that says that 1a is equal to 1c. In the end, a is equal to c. Therefore, a is equal to 2/5 or 2/5. Now I'm going to write these values again because I have fractions and it doesn't look too good. So take a look to what I'm going to do. So I have my a to be 2/5. I have b equals 1. I have c equals 2/5. I have d equals 1/10. And I have e equals, and I have e equals 1/2. So I have so many fractions. I have so many fractions, but you know one thing. We can turn fractions into whole numbers when we multiply by the denominators. For example, if I have a fraction 1/3 and I want to get the whole number, I will multiply times the denominator, that is 3. So in the end, the number that remains is going to be the numerator, okay? In this case is 1. If I have, for example, 2/3 and I want to get the whole number, I will multiply times the denominator 3, okay? And the result will be the number in the top, which is 2. I can do the same process at all times. So for example, if I want to turn 2/5 into a whole number, by what number I need to multiply?
times 5.
Times 5, okay? So my 5 and 5 will be cancelled and the whole number will be 2. So in here, as you can see, you have numbers like 2, 5, 10, and 2. So in this case, I will get the greatest denominator, which is 10. I can use 5, but in the end, you can see that it will be necessary to multiply again. So to get rid of the denominators, I will multiply times that same denominators, okay? So in this case, I will multiply times 10. But miss, maybe you're wondering, miss, what if I just multiply times 5? If you multiply times 5, you will get, here you will get 2, here you will get 5, here you will get 2, here you will get, here you will get 5/10, which is 1/2. Take a look. So when you multiply times 5, which is not the greatest denominator, it still gives you a fraction, but it doesn't mean that it's incorrect. And here, 1/2 times 5 is going to give you a 5/2. So as you can see, if you multiply times 5, still gives you a fraction. That means that you need to continue multiplying. But if you multiply one number times one number, you have to multiply all of them. So in this case, by what number would you have to multiply to get rid of the 2?
And 2.
Times 2. But you're going to multiply times 2 all of them. So here it's going to give you 4, 10, 4, 1, and 5. And those numbers are whole numbers, okay? And these are the coefficients that will appear